Hey guys, in this video we're going to be talking about two things. First, how to identify an exponential function, basically what is an exponential function, and then we're going to talk about identifying the difference between exponential growth and exponential decay. So first thing is first is what in the world does it mean to have an exponential function? Well, I have an example of a parent function over here to the right, so you can look here to see that. So what you see here is y is equal to b to the x. B is our base. It's just a number, okay? But x is our variable, right? We're used to seeing x as a variable. So basically, what an exponential function is a function that has the x in the exponent, okay? And I do want to be very clear. If you have a function with an exponent, let's say, oh, my pen's not working great, y equals x squared, okay? That is not an exponential function. And that's because the variable, the x, that's the base of the function. Okay, an exponential function is only if x is in the exponent. So for instance, y is equal to 2 to the x, or y is equal to 5 to the x. Okay, the x has to be in the exponent. Okay. Now we're going to talk some more about the base. So there's two types of exponential functions. There's exponential growth and exponential decay. So the base of the function actually determines that. And once again, base is just that letter b, and that is just going to be a number. So if b is greater than 1, so if this number here is, again, let's say the example of a 2, it could be 6, right? It could be 1.5 to the x, right? If the base is bigger than 1, then the function is an exponential growth. Please excuse my handwriting. And basically what an exponential growth is when you have an exponential function and it is increasing. Okay. If you look at the bottom of our screen here, we have an example of an exponential growth over here to the left. And what an exponential growth looks like is basically at the beginning of the function, all the way at the left, it's pretty flat at the bottom, but then it starts increasing and increasing faster and faster and faster and faster till it's going almost vertically. And it's very steeply approaching infinity. Okay. The reason this is true is because think about the nature of exponents. Exponents, they start growing really quickly. And you've probably heard the term exponential before, just, in general, when people say, like, something's getting exponentially faster or exponentially harder, it just means it's increasing at a really, really fast rate. And so that kind of makes sense here, right? It increases faster and faster and faster, and then until it's kind of out of control, like it's just shooting almost straight vertically. So that's an exponential growth. Now we're going to talk about an exponential decay. So an exponential decay happens when b is less than 1. So anytime b is less than 1, we have an exponential decay. And that means that the function is decreasing. This should make sense to us if we think about what the word decay means, right? Like growth means get bitter. Decay means sort of like to rot or go away. So decay makes sense that decay would be decreasing. And examples of exponential decay functions could look like y equals 1/2 to the x. You could see it as a decimal, like y equals 0.5 to the x. Okay, anytime b is less than 1. And we have an example of an exponential decay graph over here to the right. Okay, and you can see that an exponential decay, it starts out really, really steep over at the left side, and then over time it sort of flattens out. So it's decaying really, really quickly, and then over time that decay happens slower and slower because there's not very much to decay anymore. Please notice the shape of these two graphs, the growth and the decay. While one of them is flat, pretty much flat, and then pretty much straight up and down, and the other starts really steep and then flattens out. It's that same general shape, and this is the shape of any exponential graph. It either shows that exponential decay or that exponential growth. They'll always sort of have that curved pattern to them. Okay, and now we're going to go through some examples and just identify exponential growth, exponential decay, or determine if what I'm showing is neither of those. So looking at this graph here, um, I can see that this is an exponential function because I see one half of it is very steep, the other half is sort of flattened out, and in between is that curved pattern that we talked about. So I do know it's an exponential function. Now I'm going to figure out, is this exponential growth or exponential decay? Well, we've talked about this before, but the way you read a graph is always from left to right. So as I start at the left side of this graph, we see that my pencil is all the way up here. And if I trace this function, well, we can tell my pencil is going down. It's going down, 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 down. That means that this is a decreasing function, or in other words, I have an exponential decay. Now let's look at this function. Again, I'm looking to see, first of all, is this an exponential function? Well, yes, it looks like there's a part that's relatively flat, and then it kind of curves up and it gets relatively steep. This one doesn't seem to be increasing as quickly, but that could just mean it's a transformation of an exponential function, which we'll talk about in another video. But basically, it does look exponential because it has that curved pattern to it and has the place where it's pretty much flat and the place where it's pretty much vertical. So it is going to be an exponential. And then as I trace, again, I read graphs from left to right. I start at the left, and as I trace to the right, my pencil is going up, 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 up. So that means that I have an exponential growth. Okay. Now we're going to look at a third graph. Well, I'm going to start by figuring out, is this an exponential function? Well, as I look at the shape here, I'm noticing that it doesn't follow quite the same shape. Like, it looks like it's increasing, but it doesn't really ever have that place where it goes almost vertical. Like, it sort of flattens out, but it's never really almost vertical. And when I look at this, I'll actually notice there's an endpoint on this graph. Okay, and those exponential graphs I showed you, they didn't have endpoints because exponential functions are continuous. So this is not actually an exponential function. This is actually a square root function. Okay, and that is something that if you're in my class, we looked at a lot in the last unit. So the answer to this question is neither. Now we're going to move on to classifying exponential functions based on their equations. So we're looking here at the equation y equals 4 to the x. So again, first thought, is this an exponential function? So when I'm looking at an equation and I want to know if it's exponential, only thing I have to do is see, is the x in the exponent? And the x right here is in the exponent. So I do know that this is going to be an exponential function. But now I have to figure out if it is exponential growth or exponential decay. Remember that we know that for exponential growth, the base is going to be greater than 1. And what that means, the number that's being raised to the x's power, that number has to be bigger than 1. An exponential decay is going to happen if that base is less than 1. Okay. Here, this base is 4. So I'm going to have an exponential growth. Working through the same way here, my first thought is there an x in the exponent? Well, there is. So again, this is indeed an exponential function. Once I know that much, I want to know, is it growth or decay? So I'm looking for, is my base less than 1 or greater than 1? Well, my base here is 2/3, and 2/3 is in fact less than 1. So that means that I have an exponential decay. Now we're looking at a slightly different problem. So here I have actually a very similar function, but I'm seeing a negative sign. So that might throw you off at first, but you'll learn how to tackle it. So basically, again, same starting point though. Is there an x in the exponent? Yes, there is. That means it's an exponential function. Even if there's like another number being added, if there's a negative sign, if something's being multiplied, as long as the x is in the exponent, even if other stuff is happening, it's still exponential function. Like all that needs to be true for it to be exponential is that the x is in the exponent. So it is exponential. Now, looking at this immediately, you're probably going to see the 4, and you might think, okay, 4 is bigger than 1, so going to be growth. But I urge us to consider the properties of exponents. So we're going to look at another example. This is something we talked about a lot in the past couple weeks. If I were to have, that's not what I want. If I were to have y equals x to the negative 3, we talked about how I could rewrite that as 1 over x to the 3. Because when I have an exponent, that's the same thing as taking the reciprocal of the fraction and then making the exponent positive. I could go one step further and I could rewrite that as 1 over x to the 3rd. Okay, we talked about when you have a quotient to a power, that power is essentially distributed to the numerator and denominator. I essentially just reverse distributed it. I kind of pulled it out. And then I know this is the same because that 3 could be distributed back to that 1 and that x. Okay, but if you do 1 to the 3rd power, that would still be 1. So it leaves you with 1 over x to the 3rd. Okay, so that is how I'm going to basically rewrite our function here in order to help us understand better. So this is a negative exponent, so I'm going to go ahead and take the reciprocal of that fraction and turn it into 1/4, and then make the exponent positive. Okay, and when I do this, I can see that my true base is actually 1/4. And since that is less than 1, this is going to be an exponential decay. Right? Basically, when you see this negative sign, you know that a negative sign means the opposite, right? So when you see this negative sign in the exponent, it means it's going to be the opposite of what you think. So if it looks right away, you see that 4 and you think like growth, well, I know it's going to be the opposite because I have that negative, so I know it's actually going to be decay. Okay. We're doing one last example, and then this video will be over. But once again, we have a negative exponent. I'm checking. I do have x in the exponent, so it is, in fact, exponential, but it's negative. So we're going to have a little opposite action here. So I'm seeing that 1/7. I'm actually going to take the reciprocal of that fraction, which would flip it upside down. That would give me 7 over 1, or just 7. And once I take the reciprocal of the fraction, I can go ahead and make my exponent positive. And that leaves me with y equals 7 to the x. Since my base is now 7, I can tell 7 is greater than 1. So I know that this is an example of exponential growth. Okay, so that is it for this video. That is sort of just an introduction to this type of function. If you are unclear on the more advanced stuff about these functions, look out for those videos as well.